We're going to be going over kind of an introduction to GVERSE Petrophysics, the 2019.3 version. A couple changes have been made to the software over time, and for those of you that are new to the software, it's going to kind of be a quick overview on what the software can do and everything that we have inside of it. So today we're basically going to be going through and looking at importing log data. Kind of the first thing you'll do, get your log data into the project, and then use that data then to build out your presentations. We're going to configure some curve aliasing and name of the curve data. You know, different vendors will name curves different things. We want to make sure that we're being able to see all the data that we have available to us. Then we're going to look at setting up a Petrophysics template, taking all that curve data and then putting it into a kind of something presentable. You kind of see an example of one here on the screen. Various tracks of displaying that data, and then we can then take it, that template, and use it for log correlation in our cross-section tools. And the last thing we'll do is we'll look at setting up a UDE, basically a user-defined equation where we can take the curve data that's been imported into the project, run it through these equations, and output new curve data from that project. All right. So with that, kind of just a brief introduction again on what exactly GVERSE Petrophysics is. So GVERSE Petrophysics is our tool for analyzing log data that gets put into the project. It's got a number of different tools and functions that we can run inside of it. So the first part of that is I'm going to be importing your LAS data to view and analyze your digital log data. LAS, fairly industry standard. We also import LBS, LIS, DLIS, and ASCII files as well, but LAS is probably the most common format that you'll see that data in. You can display different types of data in tracks for the display of that curve data. This can be anywhere from linear, logarithmic display of just numerical type data, mineralogy tracks, lithology tracks, and image tracks for viewing raster images or any other kind of image that you have. You can run your curves through user-defined equations, those UDEs, to output new curve data. These will be things like water saturation calculations, pay calculations, basically just outputting any kind of curve that you want based on the data that you've imported into the project. You can then also calculate statistics on curve data, such as averages, summations, and cumulative curve data. You can run this through our curve data statistics tool. You can then also take those calculated curve values and output them to Zone Manager for use in Zone Manager, whether it be for displaying that data on a layer or building out a contour structure map. You can calculate pay zones. So you typically would calculate the pay curve through a UDE and then run it through your curve data statistics to calculate the amount of pay you have over a given zone. And then you can take your log displays over into our cross-section tools and X-section and geomodeling for correlating formation data. It just makes it a bit easier for working with that and finding out where your formation tops are supposed to be. Of course, you can also use raster images for that correlation, but this is where you can do it digitally. So with that, let's go ahead and take a look at Petrophysics here and what we can do with it. So the first thing, like I mentioned, is you'll be able to import in your LAS data directly into your project. Typically you'll want to have your well data or your wells existing first in the project. Once you have the well, you can then correlate and import the log data along with it. As long as the LAS file has a well ID that matches a well ID in the project, everything should match up automatically. However, if you don't have any well data in the project yet, you can use the LAS file to create that well. During the import process, it'll check for the well ID within the file and create that well for you so that it just doesn't stop and doesn't do anything if that data isn't there already. So your log curve import option directly here from Product Explorer, you only have the one option, LAS. In Petrophysics, I'll show that in a minute, you have other import options. But right here, just through this window, just the one option. Whenever you import in your LAS files, you're going to have the option to pull in whatever LAS files that you want to import into the project. For instance, here I have a number of different LAS files, GRI 01 through 21, 21 wells here that I have in my project. You can either choose individual files, holding the control key down, and I can click on a couple of files there to import, or I can say every file that I have in the directory here, just go ahead and import all of them. So whatever LAS files I have in that folder, it'll import everything from that folder, but it'll only be one folder at a time. So when you import, you have a couple different methods for importing it. Automatic mode, essentially all this says is the LAS file has a well ID. There's a well ID in your project. Let's tie the data together, and I'll just import all the curve data that we have. This will create a curve set called import1. And then if you have a number of different LAS files for a single well, you'll have import 1, 2, 3, and so on. The import wizard basically will give you options during the import process, essentially what to do if there's no well already in the project for that LAS file, or how to name curve sets as they come in. So the default is going to be import 1. However, if you'd like to name it something yourself, you can do that as well. The last option here is your manual mode. Manual mode will essentially stop at every file. And it'll say, okay, here's this file. Do you want it to go to this well? Here's the curve data within it, and we'll import it from there. In the case of if an LAS file does not match a well ID in your project, what you'll see is the manual option pop up, and it'll say, no matching well ID, do you want to create that well? You can create the well directly there from the import. As I've already got some of my data here in this project, I'm not actually going to run the import, but you see automatic mode and manual mode will have the finish option. It'll just import the files. And the import wizard will have where you have the options on what to do with that data as you import it. So if like I said, curve data does not contain a well ID, load it anyways, do not load or stop immediately, and handle it as a manual import option. And then here are your options for dealing with the curve set. Load to a calculated curve set, load to a new curve set, load to an import curve set. Okay. So once the LAS data is imported into your project, then you will take that into Petrophysics to take a look at and analyze that curve data. I'm going to close that real quickly. So here is Petrophysics from your icon list. It'll appear kind of as a maroon colored triangle here, GVERSE Petrophysics. This is an updated version of our Prism tool. For those of you that have maybe used GeoGraphix in the past and are not familiar with some of the changes that we've made. Prism became GVERSE Petrophysics, updating it from a 32-bit platform to a 64-bit platform. And also giving it a bit of a facelift. It's got a new look to it. There's a few new tools and features in there as well. But for the most part, all of the data that you had in there previously and all the work that you've been doing previous, it'll run the same as it did before. So you don't have to worry about losing anything just from the updating to this new platform. So this is what the new platform will look like. So it's kind of a new facelift. We have a lot of these ribbon toolbars you may have seen in a couple of our other modules if you worked in here before. Well-based got it recently with 2019.3. Geomodeling, when we updated from Smart Section to geomodeling, it kind of got this ribbon toolbar look. And GVERSE Geophysics, we updated that from Size Vision. We also gave it this ribbon toolbar look, and it's just a more modernized look that you'll see something akin to Microsoft Office or some of those other applications, where everything that you work on in here is more workflow based. Say all these tabs here representing those various workflows. The Home tab is going to contain all the basic tools that you'll be running periodically, as well as just your options for opening up information, opening up a well, opening up a template, or opening up a crossplot, plus your import options here. You have your edit for editing various things about your curve data in here, how you want to view your depth information, whether it be in feet or meters, MD, TVD, TVT, or TST. Viewing information like formation tops or fault data. various tools for data readout, interval picking, information picking, anything that pertains to the interpretation. So your UDE options, your curve data statistics options, some of your data options, how you want to view core curves, interval curves, completion curves, plus viewing data intervals and display intervals. If you want to just view a portion of the log data, you can cut off all the rest of the data and just look at it over a given zone interval. And then your apps window for opening up other applications. No longer does it have the toolbar on the right-hand side of all the various icons. It now has it here listed under the app window, which can be found on the Home tab. After that, it's based on what you're trying to do within Petrophysics. You got the View tab for things that pertain to the view, going from one well to the next, previous well, next well, select well to open up to a particular well. The refresh your view in case you've made changes to a well and you just need to quickly see what's changed. You can refresh the view. Viewing formation tops, checking your strat column, checking your curve data manager, or you can go and see kind of what curve information you have in the project, and if you have any unassociated curves, curves that have been imported that don't associate to a particular well. And then some layout options, how you want to view certain windows if you have multiple windows open. Project tab is going to be everything that pertains to the project as a whole, not just what you're working on currently in your interpretation view. These are going to be things like your alias lists, which we'll talk about here in a second, your default templates that open whenever you first open up a well, where you can check your curve mnemonics and your curve set inventory. This is where you can also check information on your curve set. What is the active curve set? Do I want to delete any curve sets? Anything like that. That's going to be pertain to everything in the project, things that affect the project as a whole. After that is your interpretation. You can have different interpretations or work in different interpretations essentially within Petrophysics. This mainly is set up through the use of UDEs, where a set of equations may be doing one thing, but then you change to a different template and a different UDE to analyze something else. You can keep those separate or keep it all in a singular UDE that does everything. So this is where your UDE options are found. Applying, editing, and selecting various UDEs, and outputting that UDE data by saving the computed curves back to the well, and then your curve data statistic calculations. I want to calculate information about a curve that's going to be based on the interpretation that you have active. After that is your curves tab. This is where you can run various tools on the curves, copying, deleting, rescaling, interpolating, normalizing, adjusting the display, baseline shifting, depth shifting of that curve data. And then after that, it's just seeing what kind of curves you have available in the particular well. Here with the edit curve data, and then your merge splice options for how do you want to handle multiple curve sets for a single well. You need to merge data or splice data together anywhere there. So this is kind of an overview of the various tabs and then working there within Petrophysics. So kind of backing up again, the first thing that we did was we imported in that curve data. And just to show you the various other import options you have in here, as I mentioned, this one has more import options than what we saw before. There's your LAS options that we used. This is the same import options that we did through Product Explorer previously. You have your LIS, DLIS, ASCII, core data, deviated surveys, DIT meter data, and then curve alias imports. This is a new feature in 2019.3. Any alias lists that you've worked on inside of one project, you can import into another. There's another method of doing that as well that I'll talk about in a little bit here. So a lot of different ways you can import various types of data. There is one there for core data and deviated surveys. However, that's just going to be one well at a time. So typically that's easier to import via spreadsheet or through your 297s or ASCII files from info, wherever you're getting that data. It's much better handled through those import options. All right, so our curve data has been imported into the project. So typically the first thing that we'll want to do is just see what curve data do we have in the project and what do we need to get set up for that project in order to make sure that we're seeing all the curve data that we need to see. And so that's going to be handled here on the project tab under our default settings. So the default settings, again, these are things that pertain to the project as a whole. This is going to be the list of all of your default curve names and their aliases that you can find in here. Now, this is all kind of pre-set up by the software automatically. So when you first start loading data in here and working in here, your default curves will be the same across every project that you create, and pretty much everybody has the same default list. But you can add additional default curves into your own list here, whereas you might have a particular curve name that you want to make as a default one, instead of having to alias it to one of the pre-existing default names. So you can just add here, type in the name of the curve, and then if there's anything alias to it, you can add that here as well. If you just want to work with the default curve names we have here, then you just can simply alias a curve name to one of these here. For instance, here I have phi in, it's my neutron porosity. And I can see here the curves that I have alias to it in phi, Cn, Cnl, Cnc, Cncf, MPOR, TMPH, MPSS. So you can kind of work your way through that list there. There's another way of viewing this information as well, which I'll show in a second. But essentially, this is also a hierarchy list where it says, okay, if I can't find a phi in curve, then I'm gonna look for an in phi. If I have in phi, then I'm gonna use and display that. After that, then check Cn, Cnl, Cnc, and work its way down that list until it finds a curve that it can plug into that alias list. If I want to add a curve to this, I can simply type in the name of that curve and separate it by a comma. MPSS was already at the end of that list, so I'm just going to go and delete it from there. We can simply just type in the name of a curve and kind of add it into the alias list that way. Another way of doing it is if I highlight or select the phi in here and say edit alias curves, and see, okay, here's all the curves that are alias to phi in. It's a little bit easier to see, and also gives you a count of how frequently that curve name shows up. So I can see MPSS is the most common name for phi in, so maybe I want to move that higher up in the hierarchy, make that the first one that it looks for instead of in phi. So I can add that up in there. And then I also get the ability to see every curve name that I've imported into the project, and then what else I might want to add to an alias under phi in. So for instance, I can take, I don't know, MINV. If I want to add that as an alias curve, I can choose that from the list and say add, which I'm not going to add here. It's not a neutron porosity curve, but essentially you'll choose one from that list and add it this way. And you can do this for multiple curves. Pull it from the drop-down list, add, pull another one from the drop-down list, add, and keep adding them that way. So then once you finish with phi in, you can go over to the next one, say row B, edit its alias curves, and kind of keep doing it that way. So this window is where you go and you'll set up the alias list, get the curves in the order that you need, and get them set to the right alias name. And once they're set up that way, then I'll be able to make sure that I'm able to visualize the correct curves at the correct time. Through here is where you can also see other default settings, such as the parameters. These will be used inside of your UDE. We'll talk more about those. Conversions, if a curve is being imported and needs to be converted to another unit. For instance, if it's coming in as %, we multiply it by 0.01 to get it into decimal values instead. So you can see the multiplier and the offsets that are being applied here. So basically just reads any kind of input unit from the various curves and then automatically converts them to something else. And this is just going to be in the case of, if the unit's being applied to the curve file from the vendor. If there's another conversion that you see in here that you maybe don't want it to run or anything else like that, you can add or delete any of these conversions or edit them on your own to do anything else you need to do. After that, you have default units. These are going to be the units that are applied to the curve information. Again, primarily going to be used in the case of conversions. And then data. This is going to be data intervals. I only want to see curve data over, from this formation top to this formation top, or this depth to this depth. You can set up a data interval and make that your default, meaning anytime you open up a well, it'll only show you data over that interval. All of those settings, that's part of the default settings. all that information is saved out to a file called the defaults.glp, which you can find here in Project Explorer. If you highlight your project, change this to all files, you'll have a defaults.glp there. So all that information, your alias list and everything else, is saved into the defaults.glp file. You can take that file and copy it from one project and move it to another if you want to use that alias list for that information over there. It's entirely up to you how you want to handle the default information. Keeping in mind that if you also copy that from one project to another, it's going to overwrite any pre-existing alias work or conversion work or anything else that somebody else may have done in there. It will overwrite that information when you copy and paste it there. Okay, so once you get your alias list set up, you've got your default curves set up, then you want to go ahead and start displaying that curve data in your templates. Now I've got a template that I've got set up here to display a couple curves. I'll show how it was created. So first, let's go ahead and open up a well and take a look at that information. So on the Home tab, I can open up a well. I have my list of wells here, 21 wells in the project, and I'll be able to see down here at the bottom as well. Here's all the wells with curves in the project, 21 of them, that have my active curve set, 21 of those as well, and that are in my active filter. I don't have a filter active now, so it's also 21. So this will only show you the list of the wells that have curve data in them. If you want to look at every well in the project, even the ones that don't have curve data, you can check the box up here to say show all wells. If you're looking for a particular curve, and it's very easy for me to find a curve, or looking for a particular well, it's easy for me to find a particular well because I only have 21 of them here. But say you have a list of thousands, you have a find tool over here that you can use to find the particular well that you're looking for, make it a bit easier there. But you can also sort these columns by well ID, operator, name, number, TD, datum elevation, just some basic header information. I'm going to go ahead and open up well number 10 here. So when you open up a well, it'll go ahead and find the default template that's going to be applied. When you first start working in Petrophysics, it's something called raw curves. The raw curves template will have the four tracks that you see here: correlation, depth, resistivity, and porosity. Those 4 tracks will be in that particular template. Everything else you see here are things that I've added myself. So whenever you're working with these templates, essentially you can right-click in here and go to Edit. You can also go ahead and right-click in here and go to Depth, Tracks, Curves, Lateral Curves, Area Fills, Data Posting. All of these will open up the same window, and then I can jump around from one of these options to the next. I'll start with Depth. So the Depth tab here is essentially how you control the depth track. What is its width? What kind of depth lines am I getting across here? Every 50 feet, I get a thick line. Every 10 feet, I get a medium line. Every 2 feet, I get a thin line. So I can increase or decrease the interval from where I get those lines there. Let's say every medium, I have 25, and then every a thin line every 10. So I can change that. You'll be able to see that there. Let's say I don't want any thin lines. So I just have every 50 and every 25. So you can kind of set up the grid system that you have applied in here, as well as viewing depth information. I can view it by the whatever your current view is at. Mine's at MD. You can also view TVD and other information in here. I'm going to shorten this track just a little bit, make it a little bit smaller. Go to the Tracks tab. In the Tracks tab, I can see the various types of tracks that I can add in here. Add a new track. Various types: logarithmic, linear, image, minerals, dip meter, facies, core description, text, and various lithology tracks. All those various tracks have different attributes and options for how you display data within them. So if you're looking to get a certain view of specific types of data, one of those tracks may work for that. You can also rename the tracks if you want to name them something else, and adjust their width and their attributes. And attributes here in this case will be dependent on the type of track that you're viewing in here. For instance, right in the ones that I have here, I can adjust the grid lines. If I want to have fewer grid lines or more grid lines, you simply click in the attributes and adjust the number of vertical lines. And if you don't want any vertical lines at all, you can toggle off the grid altogether. Curves tab will show you the various curves and which track they're being displayed in. So in a particular track, if you want to put a curve in there or take a curve out, this is where you can go in and view that. This is also where you can change the display color and line thickness of that particular curve as well. So in the first one, the correlation track, I have the gamma ray, SP, and the caliper curves. So gamma ray, SP, and caliper there. The resistivity track, I have res S, M, and D, shallow, medium, and deep resistivities. The porosity track, I have porosity, Phi-N, Rho B, and DT, as well as some core data being posted. And in the interpretation track, I have average porosity and water saturation. The pay track, I have pay and water saturation curves there as well. So each one of these, I can change the type of curve that's being put in here. So instead of, right now, I'm posting Phi-N. Let's say instead of Phi-N, I want to put one of those aliased curve names, MPSS. I can do that as well. This is where that alias listing and default curve name comes into play. If you don't see a particular curve present in the track, you may want to switch the name there, either to a default name or one of the alias names to make sure that actually does display. The line styles can be changed, as I mentioned. I can click in here for the attributes. I can change if it's a dashed line, I can change the thickness of the line, I can change the color of the line, and all that information. And if I need a backup for that curve, for instance, if it goes off scale, it'll continue off to the either the left or the right, depending on what it is. I'll have single left, single right options there. Okay. So essentially you're setting up the tracks you want and then the curves you want to view in those various tracks. So I've got all that set up the way that I need to here. Area fills, I can apply an area fill to my template. This area fill can be used to show me various lithology information or just kind of color fill and various information in there based on a left and right cutoff. So for instance, I have a sandstone area fill here applied to my SP curve. So essentially where the SP curve exists on the left, and then it goes to a -10 cutoff, my constant value here. So it's cut off there at the constant on the right. It'll fill in with the sandstone. And my porosity track, where my density and porosity curves overlap each other, where the density curves on the left and the porosity curves on the right, I filled that in with a little gas effect here. And then my pay track to highlight the pay zones, where I have pay overlapping with water saturation. Then I filled that in with the pay color. And then where I go from constant to the water saturation, I filled that in with just a water color. So I can get an idea of where my pay zones are based on that area fill. And the last tab here, your data posting. This is where you can display data along the well itself. This is going to be your perforation, your DST, your IP, zone information, core information, any information that you have about the well where it may cover various depth intervals. This information can be posted along the well bore. So for instance, I have perforation data posting along my correlation track. So it'll just look for where I have perf data stored in Wellbase. Here in the completion track, I have various number of perf stages covering various depths. So where those depth ranges are, I'll see a posting along the wellbore indicating that depth information. And the same with DST, I'm posting here in the depth track. So a lot of different things you can post along that there within the template. And I can use that downhole posting information to also help me correlate tops back in the cross section. Okay. So just a couple of the various options you have available to you for posting some of the downhole data or anything else. I'm gonna scroll down here a little bit down to about 6,500 feet where I've got a formation top here. These formation tops, again, pulling that data out of Wellbase, where I have those formation tops already stored in the formation tab. So I have a number of different formation picks in here. The formation top that I'm looking at here, I'm going to scroll down a little bit to well number 10. I have the F11 and the F11 base. So I can see the F11 and the F11 base tops being displayed. So these can be found in the formation tops here on the Home tab in the View section. Formation tops that I have available to me that I want to post, I have ranging from the B46 down to the F39. So I can see every formation that I have on the project entirely, and then just the ones that I want to display in my my curve template here. So all that is customizable, what you want to view and what you don't want to view. You can kind of post that information here. So with that, I'm able to see kind of where my F11 zone is. Got a sandstone fill kind of indicating where those tops are supposed to be, so everything kind of looks okay there. And I'm also posting a zone annotation here showing me some curve calculations that are over that given interval. So let's look at kind of where that data is coming from. So I've got the curve data put into my project, got my alias list set up, and I've got my my template set up on how I'm going to view some of that curve data. So now I want to run some calculations on that that information. The first thing you'll look at here is going to be running it through your UDE, your user-defined equations. So I can come up here and say, let's see what kind of UDEs I have available. There are a couple predefined UDEs. There's an Archie interpretation, some 3 and 4 mineral models. You can also look under system and see a couple of the other ones that are set up by the software. The ones I have here under project though, these are some other ones that I've created myself. So I can create any number of UDEs that I want, a new set, and then I can go in and insert curves and other data into that, that UDE. So for instance, here's one I have, the Frio sand interpretation. This is a UDE that I've set up and created. I can click the edit button on that, and it'll show me the curve calculations that I've got present in this this UDE. Can increase or decrease the font size within there so it's easier to read information. It'll also color code the curve data in there for me, so I have an idea of kind of what some of these calculations are doing, as well as making sure that as I type out these equations, that they're all running correctly. For instance, if I type in an if then else statement, it'll color that pink. So if I know if I mistype something in here and it doesn't change colors, then I know something is missing in there. So these equations, essentially you're taking an existing curve and you're running it through these calculations to output new curve data. And these can be based on anything for porosity calculations, water saturation calculations, shale volume calculations, sonic curves, permeability, mechanical things like Poisson's ratio and brittleness and Young's modulus, matrix identification information, pay flags. A number of these have equations that are already set up for you, so you can simply find the type of water saturation equation that you're trying to run, various types of Archie equations, and you'll just select the equation there and hit select, and it'll dump it into your equation set there for you, essentially wherever your cursor is. Got a couple things in here I want to cut out real quick. Wasn't paying attention to where I had my cursor. Okay, so those equations you can plug in there. You simply select the equation you want and then drop it in there wherever your cursor is. Essentially what these are doing is, let's say, for instance, this density porosity equation, it's going through and it's saying I have a curve here, phi d. I'm creating this curve and I'm basing it on this equation, rho m minus rho b divided by rho m minus rho f. So these are curves that I have here with the square brackets, and these are parameters here with no brackets. So that indicates a variable that's being used in this equation. So as long as I have a rho b curve, I can plug it into this equation and it'll net me a phi d curve. And then from there, I can take that phi d curve and plug it into this equation. Phi d plus phi n divided by 2 nets me a phi av. And then I take phi av and then basically just runs to this list of equations that I've got set up in here, where I can run various things like if then else statements, is null statements, pay calculations, anything that I want to in here to output that data that I need. Those parameters, those are the various variables that I have plugged into this equation. They can be based on either a constant value here, for instance, rho m and rho f, they have a constant value associated with them. or I can base them on a zone interval based on one formation top or another. So two different ways you can kind of plug those parameters into the equation where you might be changing from one lithology to another. So a particular constant doesn't make sense if it's constant all the way through the well. And that can be set up through zone definition and zone well parameter information. Okay, so that's the series of equations that I've got set up in there to output the interpretation and pay curves that I've got here: water saturation, pay, average porosity. So once I've got all that information in there, then I can start to run calculations on that curve data, my curve data statistics. So with the curve data statistics, you'll essentially choose a curve to calculate something on. Let's say my phi A, my average porosity, and then I can calculate out the average of that. I can calculate out the cumulative frequency, the summation, the maximum, the minimum, the interval depth, geometric harmonic averages, a couple different statistics you can calculate from there. Just take a basic average here. And I can average it for the entire well, and figure out what the average is over the entire, where the log data starts to where the log data ends. Or I can do it over a given formation zone, let's say from this F11 to this F11 base. So I can say from F11 base automatically fills out as it's the next formation down in lithology order. Of course, you can choose different formation from there. You can offset that information. So I'll say add here, and that'll give me the phi A average over the F11 zone. So I'm going to calculate from here to here, what is my average porosity for that average porosity curve, phi A, which you can see here is the black curve. So once I got that set up, I can go ahead and create the data, go ahead and calculate, and it'll figure out a couple of values there for me based on the input curve data that I've got in there. A couple of these will be the same. I got a constant value in there for places where I don't have a particular curve present. For instance, if I don't have a row B, then I couldn't go through those list of equations. So it wouldn't give me anything, it would give me a null value. So I've got a constant value set up in here in those cases, 0.218, where I don't have a row B. So I can kind of get an idea of over this given interval, here's my average porosity. I can save this data out to Zone Manager or Zone Application, or if I want to just analyze some of the data or store the data there, I can keep it saved, because as soon as I close out of this window and close out of this next one, these values are lost. I'll have to go back and recalculate it again to get those values again. So it's a good idea to save those someplace as a text file and Zone Manager, copy to clipboard to paste it into something else, so you can come back and use it later on for other calculations. Okay, so I've got my data imported. Alias files have been imported. My alias list has been set up. My template's been set up to view the curve data that I want. Seen where I can run it through various UDE equations and then calculate various statistics on those curves. So it's essentially your jumping off point. From there, there's a lot of number of different things you can run through in this application, but those are the basics of what you'll typically be running through there in the application, getting everything set up and ready to go. Of course, you'll have various equations and things you want to display in there, but that's essentially all you need to know to kind of get started with the application.